Welcome to Module 4. Before you study this spreadsheet, I highly recommend that you download and read the Module 04.pdf file that you found in the same place that you found this spreadsheet. This module is the beginning of the concept of the hypothesis testing, and we'll be using the same concepts throughout the quarter. So before you get going on the spreadsheet, I highly recommend you either do the reading in the textbook or read the module 04 PDF file. This spreadsheet, this presentation assumes that you've done the reading and understand the terminology and the methodology described for a hypothesis testing. So let's get started. Again, I highly recommend you read through the basics, the purpose and the learning outcomes. Understand the basics of hypothesis testing. For example, what does it mean to reject null hypothesis, fail to reject null hypothesis? What is a hypothesis? What's the difference between the null hypothesis and the alternative hypothesis? You should know what the test statistic is, critical region, significance level, critical value, and then the p-value. Also, there are a couple different types of hypothesis tests. So there's a left tail test, right tail test, and two tail test. So you should know the differences between all these different tests and when to use the left tail, right tail, and then the two tail test. The general procedure for hypothesis testing is generally the same. So you first set up the null hypothesis and alternative hypothesis. Either determine or get the information on alpha, and decide which test you're going to be used. Is it left tail test, right tail test, or two tail test? Figure out the test and then calculate the test statistic. And lastly, determine the whether the test statistic falls in the critical region, or we're going to be using the method called the p-value method. And to make a decision for the p-value method, the rule is, once you find the p-value, compare that with alpha. If p-value is less than alpha, you reject the null hypothesis. Otherwise, you do not reject the null hypothesis, meaning that if the p-value is greater than alpha, you do not reject the null hypothesis, and you proceed with your conclusion. So let's see this in action. So hypothesis testing for P. Later on, we'll be looking at different parameters for the hypothesis testing. For this one, we're going to be looking at proportion. Later on, we'll be looking at the mean and then the standard deviation. The steps are pretty much the same. So if once you understand the proportion way, you understand the one for the mean and then the standard deviation. So let's look at the right tail example. Assume that the 100 babies are born to 100 couples using the XOR method. With the XOR method, the gender selection is so that the girls are more likely. Looking at the sample, we observe 48 girls in 100 babies. Write the hypothesis to test the claim that with the XOR method, the proportion of girls is greater than the 50% that occurs without any treatment. So for this problem, the alpha is set as 0.05. If it's not given to you, you can assume the alpha is 0.05. So test the claim that with this XOR method, the proportion of having girls is greater than 50% or 0.5 proportion greater than 0.50. Or the real question is, does the XOR method seem to work as advertised? So let's take a look. First, you set up the null hypothesis and alternative hypothesis. Null is typically equal to a number, so in this case 50% or 0.50. So the proportion should be 50% girls, 50% boys. So that's the status quo. And the alternative is the proportion is greater than 0.50. We know this is a greater than because it says so in the problem, highlighted in red. So this is a key thing. For the alternative, you have to decide, is it less than greater than or not equal to, and then simple word like a greater can tell you what the sign should be. So I know this is going to be a right tail because the right tail is used when it's greater than situation, and that makes this a one tail test. So let's fill in the values. We're going to be using Z calculation. So for that, you would have the P hat, the P and Q, and then the N. So P hat is the observed P, so it's going to be 58 divided by 100, same as before. P is the proportion, population proportion. So what's the proportion of girls without the XOR method? So that would be 50-50. Q is 1 minus P, so in this case it's 0.5 and 0.5 each. Here's the test statistic calculations. So we're going to be using the Z test. That's the test statistic, and to calculate that, the formula is this. So this cell reproduces this whole formula right here. So we figure out the Z. To find the p-value, we use the function called the norm.s.dis function. But since this is the right tail, there's one adjustment you need to make, which is to make it 1 minus norm.s.dis function. So once you figure out the p-value, in this case it's 0.054799. So to make a decision, you compare this with the alpha value you're given above. So if you remember, the alpha was 0.05, so you make a comparison between 0.05 and the p-value. You see that the p-value here is greater than 0.05. So since the p-value is greater than 0.05, per the rule, we failed to reject the null hypothesis. So for the XOR baby gender test, there's not sufficient evidence to support the claim that the XOR method is effective in increasing the probability that a baby girl will be born. That's a little wordy, but you have to be very specific in your conclusion. So for your assignment, it's not enough to tell me that you either reject or fail to reject the null hypothesis. That's just a partial answer. To get the complete answer, you need the following word answer, just like in this problem. So you should practice doing both, understanding the reject or not reject, as well as the word conclusion that follows from that decision. So that's the right tail example. Let's look at the left tail example. We're going to be using the exact same problem, except that in this case the proportion of girls is less than the 50%. So how does that make any differences? Okay. So the now is going to be the same. We're still going to assume it's 50-50. But in this case, since it's less than 50%, the sign is less than. The calculations are the same. 1.6, test statistics the same. However, the p-value is different. For the p-value, we just use norm.s.dis function, and we don't need to do any 1 minus adjustment like you saw in the left or in the right tail. So for the p-value, left tail, it's going to be 0.9452. Again, it seems that the p-value is greater than the alpha. So 0.05. So again, we failed to reject the null hypothesis. So that means either way, XOR baby gender test, there's not sufficient evidence to support the claim that the XOR method is effective in decreasing the probability of having the baby girl. So the wording is a little bit different because decreasing because it's less than. Up here it was greater, so that was increasing. So you have to be very careful how you word your conclusion. So let's look at the two-tail. It's a different problem. In a sample of 100 M&Ms, it is found that the 8% are brown. Use a 0.01 significance level to test the claim that the Mars Candy Company, it claims that the percentage of brown M&Ms is equal to 11%. Okay, so the proportion, claim proportion is 0.11, 11%. So that's what we think that's what the null hypothesis should be. Alternative is that we don't know if it's greater than that or less than that. So if you don't know if it's greater or less than, we just don't know. So then we just say, oh, but we know it's not equal to 0.11. So we just set it to not equal to 0.11. So that makes it a two-tailed test. Whenever there's the alternative proportion is not equal to some number, that's a clue to make it a two-tailed test. So 100 M&Ms. We found the 8% are brown, so that's the observed number of brown M&Ms. That makes the p-hat 0.01. The claimed proportion of the Mars Company claimed proportion is 0.11 here. So that makes the q 0.89. Again, 1 minus p is q. And for the z, we follow the same formula we did up here. And we get negative 0.9588. Plug it into simply the norm.s.this function. And for the two-tail, what we need to do is we double the area. This is area for one tail, so this is a two-tail test, so we double the area or the p-value. So in this case, it's 0.337657. So compare that to the alpha of 0.01, you see that the p-value is greater than 0.01. So again, we failed to reject the null hypothesis. What does that mean? So that means there's not enough evidence to support the claim that the percentage of brown M&Ms is different from 11%. So it seems that the Mars Company or Mars Candy Company's claim of 11% seems to be valid. So this was the example of right tail, left tail, and then two tail. So you should know when to use right tail, left tail, and two tail. Moving on to the types of errors. Here's an example of type 1 and type 2 errors. Here's the definition. To understand type 1 and type 2 errors, again, I recommend you reading what the type 1, type 2 errors are, and then come back to this spreadsheet to make sure you understand what this table is telling you, both top and on the bottom. If you have any questions, let me know and I'll try to help you out. And that's it for Module 4.